Hey guys, this is Mrs. Nell. I'm going to go through each problem of the quiz that you took on Thursday, and if you have any questions, write them down, and I will be talking to you live on Monday afternoon at 1 o'clock for anybody who has specific questions. If you do not have a specific question, you do not need to go on the Zoom link. Okay, here we go. Number one, I look at this and I always like for you to draw things out. So I have a circle here, and I noticed that there were 3 points, E, F, and D. I also noticed at point E there was an angle that was 50 degrees. So I'm going to go ahead and connect E and F. Right, and I'm also going to connect E and D. That's what it looked like. Okay, and then I'm also going to connect F and D. All right, so there is my triangle. Another thing that was on the picture, but these two segments, chords, if you will, are congruent. All right, so that means that this is an isosceles triangle, meaning that these two angles, angle F and angle D, are congruent. Okay, so because that's the definition of an isosceles triangle. So if I took 180 degrees and I subtracted 50 and I divided by 2, I should get that these two angles are 65 degrees. Okay, why do I need that? Well, I am going to use the measure of the inscribed angles theorem. The measure of the inscribed angles theorem says, hey, the measure of an inscribed angle is half the measure of its intercepted arc. Okay, so I need to find the arcs. That's what it asked me to find. It told me that I needed to find, I believe, arc FD. And when I do that, so that means that I'm going to have 2 times 50, which equals 100. So arc FD, right here, FD is 100 degrees. All right, well, it also asked me for DE or ED, and so this arc right here. All right, so 2 times 65 equals what, 130? So arc ED is 130 degrees. And just for giggles and grins, so is EF, 130 degrees. And that was problem number 1. All right, so now let's look at problem number 2. So let me adjust this so you can see my circle there. All right, so we have problem number 2, and problem number 2 had 2 chords, and they were intersecting in the middle, making an X. So here's one of the chords. Here's another chord. Okay, that's my sketch. I know that one of the angles right here is 94. Doesn't really, because I'm just sketching it. Okay, this was 80, and I'm looking for X. All right, great. So I'm looking at this, and I notice that I have this chord and this chord. They intersect. Vertical angles are here. All right. I also know that this is a line that is 180 degrees. All right. So if this whole thing is 180 degrees and this is 94, then this angle has to be 86. All right, great. Now, because that makes a line, all right? So I have this theorem called the angles inside the circle theorem, because there it is, it's inside. If two chords, 1, 2, intersect right there inside of a circle, then the measure of each angle is half the sum of the measures of the arcs. Okay, so I know here that I have 1/2 80 plus x, not there, 80 plus x is equal to 86. Okay, 80 and x, those are my arcs. Half of that measure of those together equals 86. Now all I have to do is some algebra. So I'm going to distribute this, giving me 40 plus x over 2 is equal to 86. I'm going to subtract 40, x over 2 is equal to what? 46 times 2 times 2. X is equal to 92. So the measure of this arc right here is 92. That's how you did number 2. All right, so let's look at problem number 3. I've already drawn it here, and I want to show you a couple things before we find what we're looking for. First of all, I noticed that there is an intersection on the outside of the circle. That's very important. I also noticed that this line JHG, goes through the circle, creating a chord. This is a chord from H to G. JKF also goes through the circle, creating a chord right here. Well, what is that definition? That is the definition of a secant. So I have this secant and this secant, okay, because they go through the circle and they form a chord through the circle, all right? Now, what else we knew was angle J was 30 degrees. We know that arc KH is 44 degrees, and we're trying to find the measure of arc FG, and which they're called A. All right, so what do we know? Well, as I said, this is important. That angle is on the outside of the circle. So guess what we're going to use? Angles outside the circle theorem. Two secants, one there, one there. Then the measure of the angles formed is is 1/2 of the difference of the intercepted arcs. All right, 1/2 of the difference. So let's set it up. So this angle, 30 degrees, means equal 1/2 the difference of the intercepted arc, A minus 44. I put A because it's a bigger arc, okay? So now I have here 30 equals, I'm going to do the distributive property, all right? And A over 2 minus 22. I'm going to add 22 to both sides, giving me 52. A over 2 equals 52. Multiply both sides by 2. And the measure of this arc right here is 104 degrees. And that was problem number 3. All right, let's look at number 4. Number 4 was a doozy because you had to find 3 different parts. When I'm given a problem that has 3 different parts, I break it down and make it as small as I possibly can. I like to solve them in alphabetical order. So the first one I'm looking for is x. Okay. I'm not even going to write y or z on there right now because all I want to find is I want to find x. Okay, so what do I know? Well, I know that I have these two lines. They do not go through the circle. They only touch the circle at one point, which is called a point of tangency. So I know that these are two tangents, okay? I also know that I have this angle, angle x, the one I'm trying to find, is on the inside of the circle. It's not in the center, but it is on the inside. So if I use some things that I know, all right, the first thing that I need to know is I need to find x. And I know that if I combine a couple theorems, that I can use the circumscribed angle theorem and the inscribed angle theorem, okay? And in order to do that, I can say, okay, so x, measure of angle x, is going to be equal to 1/2, all right, 180 minus 44. All right, so when I do that, move this just a little bit, there we go. When I do that, and I do all of the work, I'm going to get that angle x is equal to 68. Okay, again, that was, I combined two theorems. I combined the circumscribed angle theorem and the inscribed angle theorem. And so that gave me, when I did that, 1/2 of the quantity of 180 minus 44. And that gave me x. That was easy, all right? But now I need to find y. Here's y over here, okay? That's y. Well, what else did they give me? They gave me that this was 60, all right? And so now, okay, I know that this angle is 68. I know that this is 60. I know that 60 plus y gives me the entire arc right here, and that's a pretty major arc. All right, so I wonder if I can find arc PQ. This arc right here, arc PQ. See if I can do that. Okay, let me think what I have here. Sure, I can find that arc because I know that that PQ is twice as big as 68. All right, so now I'm going to say that 68 times 2 is going to give me, what, 136? So this arc is 136 degrees. All right, so let's think what we have here. So I now know that this arc is 136. I know that this arc is 60. And I know that all three of them together should equal 360 degrees because it's a circle. And so now if I do PQ, which is 136, so PQ, all right, plus, let's say PT, plus Y gives me 360 degrees. All right, so PQ is 136, PT is 60, plus Y equal 360. All right, so that means that Y, when I do all of the algebra, then Y is going to equal 164. All right, it was that easy. Now I need to find Z. Well, I'm going to, because this is getting kind of messy, I'm going to start over again. I'm going to start here, and I have made this, and I just drew what I needed. I know that X is 68. I know that because I found that. I knew that TZ is 164 because I just found that. All right. And I know that this is a tangent line. Okay, it hasn't changed anything. It's still a tangent line. All right, and so now I know that this angle right here, angle Z, all right, is going to be half of this arc right here. And so 164 divided by 2 is going to give me 82. And I just found Z. That was it. That was the quiz.